First of all, Professor, welcome to FNL. We haven't seen you since 2013.
I think the highlight was when I was elected at the French Academy of Sciences, and they asked me to write a report with colleagues, of course, on what we call continental waters. How much water do we have, and are we going to run out of water because of the climate change, essentially? And what we discovered very easily is that no, climate change is not the reduction of water resources, it's a change of the distribution of water resources. It'll be raining more in the future than it rains today. So no one should say climate change is going to reduce globally, at the scale of the globe, will not reduce rainfall. It will increase rainfall.
Position of world population, it's not consistent with where the water supply is. Now, first of all, why is that? I suppose I could ask. But secondly, do you think with this climate change that the water will move more closely to where the bulk of population is?
20% of the world's population lives in area where they only have 2% of the water resources. So we are already an uneven distribution of population compared to the existence of water resources. 20% population, 2% of water resources. Why is that so? That's a tough question, but let me give an example. There will be plenty of water in Siberia. I was born in southern France. I had little water. In the farm where I was raised, in the summer we didn't have water, essentially. We wouldn't have the time and then all the opportunity to take a bath and so on because there's no water. Now, do I want to go and live in Siberia? Climate change is a big problem, and it will affect very much biodiversity and this and that, and men, of course. But the major problem of the planet today is population growth. Because where is this population growing? Today, we are almost in all continents, we have reached more or less a plateau. The last to have reached that plateau is Asia. Asia is not yet quite there. It's another 10, 15 years, and then it will be stable or even decreasing. But Africa is growing, and no sign of ever, slowing down and coming to a plateau. With much apprehension that Africa is going to continue that way, then we will have disasters coming, like we have today, not the coronavirus, but a drought period. A drought period. Drought is something intrinsic to the climate in the world. In the 19th century, there were two major drought periods, one in the 1870s and one in the 1890s. And the continents which were affected by the droughts were Africa, of course, Asia, and also South America, Brazil in particular. And in each instances, 30 to 60 million people died of hunger. And that can happen again tomorrow. We're not prepared to do that. We were not prepared at all for the coronavirus infection, because we do not, the politicians have a time objective, which is a few years, with 5 years maximum. It depends on the length of their assignment. If you are elected for 5 years, you think about 5 years, and you forget. You say, "Well, it's not my problem. It will be the next deputy or minister and so on will take care of that." So they don't care. The only people who care about the future and about drought is the Chinese. The Chinese have made in 2015 a big step, which is to double the amount of food they have in store. Yeah. And they decided to spend $25 billion to increase the amount of grain, of food, of whatever in China, to feed China, not to feed the world, to feed China. And this is the only sensible thing to do. If we are going to have drought, we'll have, not very logical, 10 years ago or 15 years ago, the amount of food on store at the world scale was about 10 months of consumption. So we have to store 10 months, which is reasonable. Today we have 2 months. So we have not been doing what the Chinese do, is to say to increase the stock. We have divided by 5 the amount of months of food reserve that we have. And this is a disaster. And when the drought comes, our prime ministers and presidents and so on say, oh, we didn't know, and we didn't think of that, and we didn't do nothing to prepare for that. But that's going to happen. I would say that, I'll take an example in Burkina Faso. Burkina Faso is a country of Central Africa. It rains about 900 millimeters per year. So it's plenty of water. Plenty of water. It's more than in Paris. It's more than in Britain. It's very well irrigated. However, that water comes in 3 months, May, June, July, period. And then you have 9 months of drought. So you cannot survive and do agriculture in an area which has no water during 9 months. So you have to do some kind of a storage of water in dams in order that you can spread over this 3 months of rain that you have and make it available for the rest of the time. Now, they haven't built any dams. So this is what is called economic water scarcity. Is that the equipment have not been built to provide water to those who need it at a certain time when it's not available. So water is available, but it's not available as we would like it to be, and so we have to do something.
Actually, though, as Philip said, define virtual water, green water, and blue water. What is it?
So what is green water, what is blue water, what is virtual water? Most people, when they think of water, they think of what I call blue water. Blue water is the water that you can see. It flows into rivers. That's what you see when you travel along the Thames or the Seine. And this water eventually is fed by springs and goes to the sea at the end. That's the only water on which engineers can do something, like putting it in a dam, spraying it with an irrigation system, and so on. But that's only about 1/3 of the total water resources on Earth. The other third, 2/3, is what I call green water. And green water is very easy to understand. When it rains, you see rainfall, you see the rain coming to the ground, and then more or less, even if the land is flat, you see the water going down into the soil. So it's infiltrating into the soil, and it doesn't travel very far and not very fast. So after a big rain, which may have lasted for several days, the water is stored in the upper 50 centimeters, maybe at maximum 1 meter of the soil. This is where the water is stored. It stays there. It doesn't move any further. So it stays there, and the only equipment, I shouldn't say equipment, the only system to extract that water and use it is the small roots of plants. Plants have very small roots like that, which goes into the soil and are able to withdraw that water which is stored in the upper soil and put it in the leaves, evapotranspirate it, and make production of organic matter, sugars and so on. So this is what I call, well, it's not me who called that, it's being called now green water. And green water is the major resource of water that we can use, but we cannot use directly ourselves. We have to have the plants to extract that water and transform it into food. So this is the difference. Now, what is virtual water? Virtual water is the water that is contained and necessary to produce food. For instance, if I buy 1 kilogram of wheat, well, this wheat has been produced in the field, and it can be irrigated, but most likely it will be rain-fed agriculture, and so it consumes water from the green water which I have just described and transform it into grain. Now I take that grain and I send it to Africa because they are hungry. In fact, when I transfer grain, I can say that also, I transfer the water which has been needed to grow the grain. So virtual water is that. The amount of water that has been spent elsewhere, somewhere in another part of the world, to produce the goods, in our case it's the food, that we need today. So it's not water, it's something which has been made with water, and this water can be transferred because, you know, to make 1 kilogram of wheat, you need 1,000 kilograms of water to irrigate the wheat. So it doesn't make sense to transport the water. It's much better to transport the food which has been produced with that water, and this is called virtual water. Okay?
That's very helpful, Professor. We're then talking about blue water being more adaptable, obviously, and more useful in terms of building dams or preservation for the dry months. So is there sufficient flexibility or capability potentially to adapt for certain countries? Or is that just simply too hopeful? Is it an economic argument, or is it simply, in geopolitical terms, asking too much?
It really depends on the countries. If I go to Jordan, Jordan is part of the dry zone. Jordan imports 70% of the water they need through virtual water. They do not have enough food they cannot grow anything or very much in their own soils, so they have to import food. And if I go to Djibouti, you know, the Horn of Africa,
yeah.
In Djibouti, 90% of the food you consume is virtual water imported from elsewhere. And if you go in Saudi Arabia, it's the same. There's not much water, so people import food, and they live very good life. That's not a problem. But they import the water they need in terms of under the form of virtual water by the food they buy on the international market. So can we, for instance, if the question you asked me, can we feed Jordan without transport of food? No, there's no way. Does it make sense to transport water to Jordan? Where would you get that water anyway? So by boats, it's much too expensive. As I said, you need 1,000 more weight of water than the weight of the food, so you cannot transport that with boats. It makes sense to transport water, for instance, when you have a high mountain, like the Rocky Mountains in the US or the Himalayas in Asia, and then there's plenty of water which comes at high elevation and then flows down. And you can divert that water and bring it where you want it to be used. And that's what the Indians should be doing. The Indians are going to have a big problem because they have a lot of water coming from the Himalayas in the northern part of the country and nothing in the south, or not enough in the south. So the only rational answer to the water problem in India is transfer water from the north to the south. But the Indians have failed for the last 20 or 30 years to agree on, you know, building canals and bringing the water from the north to the south. So they're going to have big problems of feeding the people in the south. The only one who are serious about that is the Chinese, and the Chinese are building 2 huge canals to bring the water from the south towards the north, from the Yangtze towards the Yellow River, and toward the Beijing area. And they're doing it with millions and billions of dollars or euros to build the equipment, and they need to do that. But it's really a question of money. Who is going to pay for these large transfers, and where do you need the water, where you can take it, and where can you transfer it?
Examples where pipelines are used for water from one country to another.
The global answer is yes, I think so. There will be more transfer. Now, is the Libyan case a good example? I'm not sure. Because first of all, Libya takes water by pumping in aquifers in the Sahara Desert. And in the Sahara Desert, as I said earlier, there's no rainfall today, or very little. So the rain they're collecting in their wells in Central Sahara is water that infiltrated 6,000 years ago. So it's what I call, fossil water, because today there's no or very little recharge. So their system can perhaps last maybe 100, 200 years, but after that, the water will dry up in the Sahara. Now, the second thing, I'm not sure about the numbers, but I've been told several times that the cost of building this huge transfer of water in Libya is so large that they would have been better off desalinating seawater to produce the water than what they're doing with transferring it by wells and then by thousands of kilometers of pipes to bring it to the coast. Because in Libya, everybody lives around the coastal zone. Otherwise, you're a desert, so it's not possible to live there. So you need the water along the coast. Why not take it from the sea and desalinate it?
40% of the world's liquid natural gas. Serious drought problems. They reckon they're going to have a major problem by 2025. So on one hand, the world needs the gas that Qatar produces. On the other hand, they are so dependent on desalination, it's almost incredible. I mean, how is that sustainable? Because I thought desalination was meant to be used after you had used other sources of water supply.
Well, if you have no alternative water supply than desalination, then what do you do? I've never been to Qatar, but Qatar is in the Arabic Peninsula, and of course there's very little. They may have a few small aquifers, but not commensurate to the water they need. So they probably have no alternative to desalination. But the real problem with desalination is that you consume energy, and Qatar in particular, and all those countries use energy from fossil fuels, gas or oil. And that's a disaster for the climate. So it is not a good idea.
What you're saying is that in many countries, I suppose particularly in Africa, there's no obvious, easy or economically viable adaptation that would mean that there's more blue water, or that it can be obviously transferred, and virtual transfer is too expensive as well. So that leads to the conclusion of population growth is not economically viable.
Every year, the population increases by 70 million people, 70 million every year. So, that's more than the population of France. So we have to accommodate at the world scale large population, which comes every year. And what do we do? I think there is water in Africa, since the essential problem is in Africa. There is water in Africa, and there are ways, if you do the investment needed, to keep most of those people in Africa and have them live, to be fed and live a normal life if we produce the equipment that allows that. But we're not doing that. Now, if we don't, what's going to happen? It's going to happen that we have one day one big drought. So people start dying by the thousands every day or every hour. So what do we do then? My major fear is that people will start fighting between each other. If you don't have enough food for everybody, then the strongest will win and eat, and the weakest one will not eat. So this intention of migration is triggered by the lack of food, is triggered by the desire to have a better life, and is triggered by the fact that we do have room here. We're not crowded. In France or in Britain or in Europe in general, there's plenty of place. If you think we are too crowded in France or England, go to Bangladesh and look at how many people there are per square meters.
We've touched on previously on this issue about what about other commodities? What about rare metals? What about minerals? What about base commodities, sand and so on? Because I think from some of your work, you've intimated that that could be a drag on global growth as well.
Okay, I want to back up a little bit on your question, because if you do not have enough food in your own country and you don't have enough water to grow that food, what do you have to do? You have to buy the food in the open market, in the international market. By the way, you're aware that more than 30% of the food that is consumed in the world today is transported. It comes from a continent to another and so on. So you are in the business, so you know that a lot of food is transported, and 30% is not a limit. It could be higher. However, those who need the food need to pay for it. So if you do not have food, you have to have money to pay for the food that you import. What can you sell? Well, you can sell, if you are very bright and you can have intellectual properties, you can sell that. But that's difficult. Well, you can sell tourism and beaches, and you can have tourism, people coming to the beaches. That's what Tunisia is doing. Tunisia is living essentially on tourism because they have nice beaches and they have built beautiful hotels, and people come and spend money and they get their money. If you don't have that, the only thing that you can sell is mineral resources. And that many countries do that. Morocco sells phosphates. Of course, all the oil countries sell oil. And a country like Namibia, which has a lot of mineral resources, try to build mines and to export minerals that can help them, pay the imported food. So the good news is that, for instance, I looked a little bit in detail of lithium. Lithium is needed for batteries, and everybody wants batteries for the cars, for anything. There will not be a shortage of lithium in the 21st century. There will not be a shortage of lithium in the 21st century. That's an economic geologist who told us that. Because, mining is very much concerned by the price of the metal. If you say metal at a good price, then you can open mines at low grades. If the cost of the metal goes down, then you must focus on very rich metals, very rich mineral ores. And given the amount of metals we know today in the earth, there will not be any shortages, provided we are ready to pay for the cost, which is to extract those metals we need from low-grade minerals. Now, when you do that, what happens? And then take the example of lithium. You can find an alternative to using lithium is to use sodium. And you have batteries which can be not as good as lithium batteries, but reasonably good compared to lithium batteries using sodium. And sodium you have everywhere. So when the price of a commodity or a metal or something comes too high, then an alternative technological solution comes up and solves the problem without having to pay the high prices. So it's very difficult to give a prediction of what will be the metals that will be needed, because we have already these two alternatives: mine ore bodies with lower grades, and then replace a technology with another one. And that can, we don't know even today what are the technologies that will be used in 10, 20 years from now. So the thing is, for sure, we will not be, deprived of any metals in the 21st century. I'm not talking about the 22nd or 23rd. I say that for the 21st century, there will be enough resources given those two factors which I mentioned.
What you're saying is that difficulties or constraints or lack of capacity for global trade and development growth is more around political issues, more about willingness to spend or not spend. Although population growth clearly has this, does have this major impact on food availability and so on. But generally speaking, world population and growth ought to be feasible if there was a willingness, which of course is a big if, but if there was a willingness for people to cooperate and work together. And that, I suppose, begs the question then, where do we see the major shifts in terms of future development? Do we just say Asia's now developing rapidly under China's auspices, and then it becomes Africa's turn? Or are you saying that it may not come to Africa despite their population growth, or India for that matter?
I like to be a prophet to answer that question and know what's going to happen. There's clearly quite a large amount of resources in Africa. You have water, large amount of big rivers. You have soils. The soils in Africa are not very good and they are fragile, but you can still exploit it and grow things on that. You have the natural forest. You have all kinds of resources in Africa, and you have growing needs for activities, because all those young people that are born today, they need to be employed. And if they are not employed and doing something, what do? They become fighters in jihad. They do the jihad. And if you go to Niger, all the young kids who are 3, 4, 5, 10 years old, their only objective is to be big and grown enough to be able to buy a gun and do the fiesta, the jihad. So there's necessarily a problem of finding jobs to those millions and billions of people that are coming to Africa. And of course, this is a political problem.
Marsily, thank you very much indeed. FNL are delighted with the depth and breadth of your views, intellect and good judgment. So thank you very much indeed.
Well, thank you very kind for your kind words.